Welcome students. In this part of the chapter Electrochemistry, I am going to discuss an interesting topic, that is batteries. Since it is related to the chemical reactions which are occurring in batteries or the cell which used in our daily life. So let's start. Batteries. A battery is an arrangement of electrochemical cells used as an energy source. One of the main use of galvanic cell is the generation of a portable electrical energy. The term battery is generally used for two or more galvanic cells when they are connected in a series. However, for a battery to be a practical use, it should be reasonably light, compact, and its voltage should not vary appreciably during its use. So the battery is basically a galvanic cell. It is an arrangement of galvanic cell. You can see here in this image also the battery. Suppose a cell is here, it contains two electrode, negative part and positive part, and they work as the electrochemical or the galvanic cell works when chemical energy converts into electrical energy and it generates energy here. Now, types of batteries. There are mainly two types of batteries. One is primary batteries and second one is secondary batteries. Primary batteries are those batteries in which the reaction occurs only once. After use over a period of time, battery becomes dead and cannot be reused again. So such type of batteries are known as primary batteries. The batteries which cannot be reused again, such type of batteries are known as primary batteries. Whereas secondary batteries or cells are those batteries in which the reaction can be reversed by the external electrical energy source, and such type of battery can be used again. So this is the difference between primary batteries and secondary batteries, and also primary batteries are not rechargeable. Some examples of primary batteries: dry cell, mercury cell, these are the example of primary batteries. Similarly, secondary batteries, these batteries or cells can recharged by passing electric current and can used again and again. These are also called storage cells, as they can store the charge, they can store the current by recharging them again. So they are also called as storage cells. Example for secondary batteries are lead storage battery, nickel cadmium storage battery or cell. First of all, we will discuss primary batteries. In primary batteries, the example of primary battery is dry cell. Let's see the process of dry cell. The most familiar commercial cells are dry cells. These are used in torches, calculators, toys, clocks, transistors, etc. Basically, dry cells are used in our daily life. The cell consists of a zinc container and that also acts as anode. This cell consists of a zinc container and that zinc container acts as anode in the cell. And the cathode is carbon or a graphite rod surrounded by the powdered manganese dioxide and carbon. The cathode in this cell is a carbon or the graphite rod which is surrounded by the powdered manganese dioxide and carbon. The space between the electrodes, the space between anode and cathode, is filled up by a moist paste of ammonium chloride and zinc chloride. This free space you can see in the image also. This is the image of a dry cell. The cell or the battery which are used in torches, calculator, those are the dry cells. In these dry cells, the zinc, this is zinc rod, and this zinc rod acts as anode, whereas this is the carbon rod. This is carbon rod which is attached with positive and negative terminal here. This is carbon rod. This carbon rod acts as cathode here. Now the space between zinc and carbon rod is filled up with moist paste of ammonium chloride and zinc chloride. So this is the space between anode and cathode part. So it is filled with moist paste of zinc chloride and ammonium chloride. You can see here this is positive terminal of the battery and this is the negative terminal of the battery. As the reaction occurs inside the battery, then the battery will provide us electrical energy. Now let's see the reactions of the dry cells. The zinc case has an outer insulator of cardboard case. During the use of zinc case gets consumed and in the end it will develop holes which are responsible for leakage. The leak-proof cells have an iron or steel sheet covering the zinc. The electrode reactions are complex, but they can be written approximately as follows. At anode, since zinc behave as anode, so at anode zinc will get oxidized. Zinc rod will get oxidized to its oxidized state, that is zinc metal to Zn2 positive ion after losing 2 electrons. When the cell is working, zinc loses electrons and Zn2 positive ions dissolved in the electrolyte. The electrons pass around the external circuit and are taken up at cathode. And at cathode, since cathode contains the graphite rod and the moist paste of ammonium ion which is covered with carbon plus MnO2 manganese dioxide. So at cathode MnO2 will be there, and we know that at cathode the reduction of metal takes place. So here MnO2 is in its plus 4 oxidation state, here manganese is in its plus 4 oxidation state. After reduction it will get its plus 3 oxidation state. By gaining of 2 electron it will get converted into its reduced form. So twice of ammonium ion plus twice of MnO2 plus 2 electron, it will give us 2 MnOOH plus twice of ammonia. The cathode reaction. In cathode reaction, manganese is reduced from plus 4 oxidation state to plus 3 oxidation state. Ammonia produced in the reaction forms a complex. Here ammonia is formed after the reduction of ammonium ion, since ammonium ion is NH4 positive. After the reduction of this ammonium ion, it will form NH3 ammonia here. So and this ammonia then combines with the zinc ion which is produced, which is dissolved in the electrolyte, and they will form a complex, and the complex is ZnNH3 whole 4 2 positive. This complex prevents the seal of the cell to crack because of developed pressure. Then the overall reaction after combining the equation of anode and cathode, the overall reaction for the dry cell comes as zinc plus twice of ammonium ion plus twice of MnO2 gives zinc ion Zn2 positive plus MnOOH plus twice of ammonia. This zinc positive ion and ammonia combines together to form a complex, and this complex provides the seal of the cell from the breakage. The cell has a potential of nearly 1.5 volt. And this dry cell does not have an indefinite life because NH4Cl being acidic corrodes the zinc container even when not in use. As we are using ammonium chloride as an electrolyte which is in the form of moist in the dry cell, so this ammonium chloride being acidic, it can corrode the zinc container even when the cell is not in use. As you have seen that the cell itself ends after some time without any use even. So due to why it is so? Due to the presence of that moist ammonium chloride which corrodes the zinc container, so the cell gets end even when it is not in use. Come to the next type of primary cell, that is Mercury cells. This cell has found use in small electrical circuits as hearing aids, watches and cameras. It consists of zinc mercury amalgam as anode and a paste of mercury oxide and carbon as the cathode. A paste of HgO and carbon as a cathode. The electrolyte is the paste of, here in the mercury cell, the electrolyte is the paste of KOH and ZNO. You can see in the image also these type of cells, these are also known as button cell. These type of cells are known as button cell or the mercury cells. This part is the anode part, which is zinc mercury amalgam. Here this is the anode part, which is a zinc mercury amalgam, and this part is cathode part. This blue part is of cathode part, which is HgO and carbon, which is a paste of HgO and carbon in this mercury cells, and the electrolyte which is here, which separates anode and cathode. Here the separator, this is the electrolyte, and the electrolyte is a paste of KOH and ZNO in the mercury cell. So the reaction at anode is as zinc amalgam plus 2 OH negative ions gives zinc will get oxidized. After getting an oxygen from OH, the zinc will get oxidized because at anode oxidation takes place. So zinc will get oxidized to ZNO after taking one oxygen from OH negative ion, and the remaining atoms are 2 hydrogen and 1 oxygen atom. So it will form water molecule. So ZNO plus water molecule plus loss of electron, 2 electron are lost in the process. At cathode, the reaction of mercury oxide plus water plus 2 electron, it gives reduction of mercurous oxide to mercury, Hg plus twice of OH negative ion. So on combining the equation, what will we get? We will get an overall reaction as zinc mercury amalgam plus HgO plus ZNO plus mercury, which is in liquid form. From here, the cell potential is approximately 1.35 volt and remains constant during its life. The cell potential remains constant during its life. It remains 3.15 volt. Why? Because the overall reaction, this is the overall reaction, and this overall reaction does not involve any ion in the solution. You can see here also the ions in the overall reaction are not there. They all get cancelled. On combining the equation of anode and cathode, in the overall reaction, all the ions get cancelled. So the cell potential for mercury cell remains constant during their life. Now come to the second type of batteries, that are secondary batteries. These batteries can be recharged and used again and again as a source of electrical energy. Mostly they are used in automobiles. So first example of secondary batteries is lead storage battery. It is commonly used in automobiles and inverters. It consists of lead anode and a grid of lead packed with lead dioxide PbO2 as cathode. Here lead Pb act as anode and lead dioxide PbO2 act as cathode. And a 38% solution of sulfuric acid is used as an electrolyte. So at anode, lead is oxidized to lead 2 positive ion and PbSO4 is formed. Similarly, at cathode, PbO2 is reduced to Pb positive ion and PbSO4 is formed. This can be seen in the image also. These are two electrodes. This negative part is anode and this anode consists of lead. This is of lead. This electrode is of lead, and this is the positive terminal, which is cathode here, and the cathode part is of lead dioxide, PbO2, and the electrolytic solution is of 38% H2SO4. The cell reactions when the battery is in use are: at anode, we have already discussed that at anode lead is present as anode, so lead will be get oxidized to lead positive ion, and this lead positive ion on further reaction with sulfuric acid, it will react with sulfuric acid, which act as an electrolyte in the lead storage cell. So Pb2 positive combines with SO4 2 negative and it forms PbSO4. So the net reaction at anode comes to be lead plus SO4 2 negative gives PbSO4 plus 2 electron, loss of 2 electrons are there. Similarly, the reaction at cathode, since the cathode act as PbO2, lead dioxide for lead storage cell, so then PbO2 plus 4 of hydrogen ion plus it gains 2 electron, it gets converted into Pb2 positive plus water. And this Pb2 positive ion further combines with the ions of electrolyte. Since this Pb positive ion released in the electrolyte and they combines with the ions which are present in the electrolyte, and the ions present in the electrolyte are, is of sulfuric acid anions, it combines with the anion and forms PbSO4 here. So the net reaction at cathode will be PbO2 plus 4 of hydrogen ion plus SO4 2 negative plus 2 electron, gain of electron is there, plus PbSO4 plus water molecule. Now the overall net reaction for the lead storage cell will be lead plus lead dioxide plus twice of H2SO4. H2, how it is twice of H2SO4? Since 4 of hydrogen ion and SO4 2 negative ion at cathode, and at anode SO4 2 1 of SO4 2 negative ion is present. So on combining all this we will get twice of H2SO4 plus it gives twice of lead sulfate PbSO4 plus twice of water molecule. Now during the working of the cell, lead sulfate PbSO4 is formed at each electrode, at cathode as well as at anode, and sulfuric acid is used up. The sulfuric acid which is present in the electrolyte, it will get used. So as a result, the concentration of sulfuric acid gets decreases. As the sulfuric acid gets used, so the concentration of sulfuric acid which is present in the electrolyte will get decreases, and the density of the solution also decreases. Now the reaction which we have discussed for the lead storage battery, that was for discharging of the battery. Now discuss for the charging of the battery. When the cell can be charged by passing electric current of a suitable voltage in the opposite direction, the electrode reaction gets reversed. As a result, the flow of electron gets reversed and lead is deposited at anode and PbO2 lead dioxide on the cathode. The density of sulfuric acid now gets increases. It will be reversed as that of discharging. In case of discharging, the density of sulfuric acid gets decreases, but in case of charging, as all the electrode reaction are reversed, so the density of sulfuric acid also gets increases. Now the final reaction for that is, final reaction will also get reversed as that of discharging reaction. Now the final reaction for recharging of the battery is twice of PbSO4 plus twice of water gives lead plus lead dioxide plus H2SO4. It's just reversed of the reaction of discharging of the battery. So in case of when the battery is in work, when it's get discharged, then the cell or the battery act as electrochemical cell. But when the battery is on recharging, when the process of battery is in recharging, then the battery act as electrolytic cell. It acts as electrolytic cell since we are providing the electrical current or the electrical energy to the battery. Then the battery gets converted into then that electrical energy gets converted into the chemical energy after reversing the reaction of discharge process. So this is about the lead storage battery charging reaction and discharging of the battery. Next type of the cells are nickel cadmium storage cell. It has longer life than the lead storage cell but more expensive than lead storage cell. However, it has some advantage because it is smaller and lighter and can be used in portable and cordless appliances. This nickel cadmium storage cell consists of cadmium electrode, cadmium anode and a metal grid containing nickel dioxide as cathode. Here cadmium acts as anode and a metal grid containing nickel dioxide acts as cathode. The electrolyte in this cell is KOH. The reaction taking place during discharge are: at anode, cadmium takes two OH negative ions from KOH from the solution, gets converted into cadmium oxide. It will get oxidized, plus water plus 2 electron will be removed. And at cathode, NiOH whole thrice gain 2 electron plus 2 electron gives NiOH whole twice, nickel hydroxide plus 2 OH ion in the solution. So the overall reaction during the discharging of a nickel cadmium storage cell is this. And for charging of the nickel storage cell, again the reaction can be reversed. We can for the final reaction of the charging of the nickel cadmium storage cell, the reaction can be reversed for the charging process, as on charging we have to provide electrical energy and that electrical energy will get converted into chemical energy. So all the electrode reaction will get reversed when the cell is at charging process. So it's all about today, and it's all about the storage primary cell and secondary cell. For the next topic, we will meet in our next video. So for that, thank you.